The MD-11 was never supposed to be a new airplane. McDonnell Douglas was out of money and out of time, so it took the DC-10 and stretched it, cut the crew from 3 to 2 and shaved the tail down to save fuel. Every one of those decisions worked on paper. Some of them came back later at an airport in weather with the runway already underneath. Don't forget to subscribe to Terra Obscura. Swissair was losing money in the late 1990s, and one of the things it tried was selling entertainment. The airline installed a new in-flight system on its long-haul fleet, letting first and business class passengers watch films, play games, and gamble at their seats. It was ahead of its time in 1998, and Swissair was the first operator anywhere to fit such a system to the MD-11. The wiring for that system ran through a space above the cockpit ceiling that crews call the attic, an inaccessible void holding structure, ducts, and cable runs. Under the fire protection rules of the day, it belonged to the category of areas where fires were considered so unlikely that the regulations asked for neither a smoke detector nor an extinguisher. On the 2nd of September 1998, Flight 111 left New York for Geneva with 215 passengers and 14 crew. Somewhere over the Atlantic, a high-power wire feeding the entertainment system began to arc inside the attic. The circuit breaker stayed closed because it judged faults by comparing current against time, and this particular arc sat inside the normal curve. The arc found the insulation blankets. They were wrapped in metallized polyethylene terephthalate, a material that takes real effort to ignite and keeps burning once lit. McDonnell Douglas had fitted it to aircraft built between 1981 and 1994. At 10 that night, cruising at 33,000 feet off Nova Scotia in Canada, First Officer Stephen Lowe noticed an odd smell. Captain Urs Zimmerman saw a thin wisp of smoke come down from the ceiling near an air conditioning vent at the back of the cockpit. Lowe got up to look and the smoke was already gone. Smoke from an air conditioning system is usually brief and rarely serious, and pilots were trained to isolate it and move on. What reached this cockpit had come through a seam in the ceiling and drifted to the nearest opening, which happened to be that vent, so the crew read it as the ordinary kind. At 14 minutes past, Zimmerman called Moncton Control and declared pan, one step below a mayday, and asked to return to Boston. Boston was more than 500 kilometers behind them and had a Swissair maintenance base. The controller offered Halifax instead, 103 kilometers away, and the crew took it. They descended and put on oxygen masks. Zimmerman told the cabin they would land in 20 to 30 minutes and to prepare the passengers. Lowe leveled off at 8,000 feet rather than continuing down to give the flight attendants more time. The airplane was above its maximum landing weight, so they asked for somewhere to dump fuel, and the controller turned them out over St. Margaret's Bay. Then Zimmerman worked the checklist for smoke of unknown origin. Its first item was to cut electrical power to the cabin, so he did. That switch also stopped the recirculation fans, which had been drawing the fire backward and away from them, and the airflow reversed and pushed it forward toward the avionics directly above their heads. 24 seconds later, the systems began to go, starting with the autopilot. Both pilots keyed their microphones and declared a mayday at the same moment. A yaw damper failed, then a flight computer, then the transponder, then the radio in mid-sentence. Zimmerman shouted that something was already burning as the fire came through the ceiling into the cockpit. Lowe said his instruments were going dark and switched to the small standby gauges on the center console. Seconds after that, both recorders stopped, and the airplane flew on for another 6 minutes, cut off from everyone. What is known about those minutes comes from the wreckage. Zimmerman left his seat and never came back. Someone tried to beat the flames down with the emergency handbook and melted its laminated pages together. Somebody switched the main electrical source, and the transponder came back for 14 seconds. Lowe shut down the center engine, and recovery crews found a checklist book open at the engine fire procedure. In the last minute, the ceiling itself melted and dripped liquid aluminium onto the jump seat. Investigators found smoke damage only as far back as first class. Most of the passengers probably never knew. At 18 seconds past 10:31, Flight 111 hit the Atlantic 10 kilometers off Peggy's Cove, 20 degrees nose down in a steep right bank at over 550 kilometers an hour. The impact disintegrated the airplane and killed everyone aboard. Canada's Transportation Safety Board ran the largest investigation in the country's history. Divers, then trawlers, then a full dredging of the seabed recovered 98% of the aircraft by weight, more than 3 million pieces, which were sorted in a hangar and rebuilt onto a mock-up frame. Investigators went through thousands of meters of wire looking for arc damage, eliminated every candidate that had burned as a result of the fire, and were left with one wire in the aft right corner of the attic. It fed the entertainment system. The board also established that none of it would have mattered. Had the crew turned straight for Halifax at the pan-pan call and flown directly to the runway, the earliest possible landing was 4 minutes before the crash, by which time the instruments, autopilot, and flight computers had already failed and the fire was burning openly in the cockpit. The fire had also taken out the slats and the anti-skid, so stopping on the runway was out of the question. McDonnell Douglas had known about the insulation. After a run of 7 fires in 1994 and 1995, and a warning from Chinese authorities, the company tested the material itself, confirmed it would burn, and issued a service bulletin in 1997 recommending operators remove it. The bulletin was advisory. The American regulator took no action, and hundreds of aircraft were still flying with the material when Flight 111 went down. Stripping it out became mandatory in 2000. Flight 642 came into Hong Kong from Bangkok on the evening of the 22nd of August, 1999, a stop on its way to Taipei, with 300 passengers and 15 crew. Check Lap Cock had been open for less than a year. At 700 feet, the crew were given a final wind check, 320 degrees at 28 knots, gusting to 36, coming in on runway 25 left that worked out to a crosswind of roughly 26 knots with gusts to 33. The airplane had been tested to 35. They were inside the number, on a wet runway, in a storm. The approach ran normally until the last 50 feet. The MD-11 was sinking faster than it should have been as it crossed the threshold, and the flare needed to catch that sink. At around 50 feet, the auto throttle pulled the engines back to idle, which is what it is designed to do, and the sink rate got worse. The captain never added the thrust back and never got the nose up enough to arrest it, so the airplane touched down at about 18 feet per second against a structure built for 12. It was also rolled slightly right when it hit, so all of that force went through one leg. The right main landing gear collapsed. The number 3 engine and the wingtip dragged along the runway surface, and the right wing tore away from the fuselage. The left wing was still attached and still making lift, and that lift rolled the aircraft over onto its back. It slid down the runway upside down and burning, went off onto the grass, and stopped 1,100 meters from the threshold with the rear of the fuselage on fire. Rescue crews were on it within minutes, which is why the numbers read the way they do. The crash killed 3 passengers, 50 people were seriously hurt, and 153 had minor injuries, with 219 taken to hospital. All 15 crew got out. 312 people came out of an inverted burning widebody in a tropical storm. Hong Kong's Civil Aviation Department put the cause on the commander's failure to arrest the high rate of descent at 50 feet and named the autothrottle's reduction to idle as a factor alongside the gusting crosswind. 18 against 12 is the whole story. The MD-11 lands faster than the aircraft it replaced and carries little structural margin above its design sink rate. A few knots too fast, a slight roll at the wrong second, and a hard landing becomes a wing separation. China Airlines still flies Hong Kong to Taipei, now with Boeing 747s and Airbus A330s. Most of the world measures altitude in feet. China measures it in meters, as did the Soviet Union, and as North Korea still does. So a pilot flying into Chinese airspace converts every clearance he is given in his head. 1,500 meters comes to 4,900 feet. Flight 6316 pushed back from the freight ramp at Shanghai Hongqiao at about 3:45 in the afternoon on the 15th of April 1999, bound for Seoul with 86 tons of cargo. Weather was clear. 3 men were aboard, a captain of 54, a first officer, and a flight engineer, and the MD-11 had been delivered new to Korean Air as a passenger aircraft in 1992, before conversion to a freighter 4 years later. They took off from runway 18 at 4:01. 67 seconds later, the captain disconnected the autopilot and continued the climb by hand. Shanghai Departure Control then cleared them to turn left toward a waypoint and climb to 1,500 meters. The first officer acknowledged it correctly on the radio, and when he passed it to the captain, he said 1,500 feet. The captain flew the airplane up through 1,500 feet and kept climbing. He was watching an altimeter set in feet, doing exactly what he had been told, and the number in front of him ran further past his ceiling with every second. At around 4,500 feet, he asked the first officer twice to confirm the assigned altitude, and twice he was told 1,500 feet, which by his own understanding put him 3,000 feet above his clearance. He pushed the control column forward. The MD-11 went over into a steep descent. This is an aircraft with a shortened tail and very little natural damping in pitch, being flown manually at low altitude by a man convinced he had to lose 3,000 feet immediately. Both pilots then fought to pull out of the dive they had just created, and the recovery inputs went the same way they went at Newark and would go at Narita, arriving late and arriving large. The airplane came down about 11 kilometers southwest of the airport into an industrial development zone at Xinzhuang in Minhang District. It hit housing occupied by migrant workers and exploded. The Shanghai Earthquake Administration recorded the impact as the equivalent of a magnitude 1.6 tremor. The crash killed all 3 crew and 5 people on the ground, 2 of them school children, and injured around 40 more. The initial examination 2 weeks later found no evidence of an explosion or a mechanical failure before impact. The joint Chinese investigation gave the probable cause as the crew's loss of altitude situational awareness resulting from the clearance being wrongly relayed by the first officer, together with the crew's overreaction with abrupt flight control inputs. Korean Air and the South Korean Transport Ministry pushed back and argued there had been a defect in the aircraft. The Chinese authorities' answer in the report was that a defect could not be ruled out, which is as far as it went. Shanghai landed on an airline that was already in serious trouble. Korean Air had suffered 12 serious accidents since 1990, and this was its 4th hull loss in the 20 months following the Guam disaster of August 1997, which killed 228 people. In one 2-month stretch, the airline had 7 landing incidents. The response went further than anything the industry had done before. South Korea's president called the airline a national embarrassment and flew on its smaller rival to the United States, rather than use it. The government imposed sanctions, and the American Department of Defense told its personnel to stop flying Korean Air. The founder stepped down, and the board moved his son aside from the presidency. Foreign investigators and outside consultants came in, and Korean Air spent the next several years rebuilding its cockpit culture around the problem everyone outside the company had already named, which was that first officers did not contradict captains, and captains did not expect to be contradicted. The airplane had done this before, twice in 1994. It bounced on landing in January, then bounced again at Anchorage in November, and struck its tail. FedEx repaired it both times, and the safety board later confirmed the work had been done properly, so the aircraft went back on the line and kept flying. 3 years later, it was still on long-haul freight runs, and someone had renamed it Joshua 9 days before the end. Flight 14 had started in Singapore on the 30th of July, 1997, and worked its way east through Penang, Taipei, and Anchorage. A fresh crew took it over in Alaska for the last leg to Newark. Aboard were the 2 pilots, a jump seat rider, and 2 people in the cabin, which is normal on a freighter carrying nobody who paid for a ticket. They arrived over New Jersey at 1:30 in the morning under clear night conditions, with 2 things already working against them. The left landing light was inoperative, and runway 22 left, the longer of the 2 parallels, was closed. That left them 22 right, with a usable 6,860 feet beyond the glide slope intercept point. The captain ran the numbers on the onboard performance computer and found that medium auto brakes would stop them with room to spare. He also knew something the computer did not account for. The left thrust reverser was inoperative, and the maintenance log carried entries where the auto brakes had failed to activate on landing. He was taking a heavy freighter onto the shorter runway with 1 reverser and a braking system he had reason to doubt, and he wanted the wheels down early. The approach ran normally, and the airplane arrived at the threshold where it should have been. In the flare, the captain pushed the nose down to plant it, which produced a higher sink rate than he wanted, so he pulled back, which produced a balloon, so he pushed again. This is a pilot-induced oscillation. The pilot's corrections arrive out of phase with the aircraft's motion, so each input makes the next swing bigger rather than smaller. The MD-11 is unusually vulnerable to it, because the shortened tail gives the pitch controls very little damping, and because the aircraft arrives at the runway carrying more energy than the one it replaced. The MD-11 hit the concrete, bounced back into the air, and came down again 1,100 feet further on. On that second touchdown, the right main landing gear gave way. The number 3 engine and the right wing dragged along the runway, and the wing spars broke. The airplane rolled to the right, slid off the side of the runway, and came to rest inverted and burning. All 5 occupants were up in the nose, which stayed intact, and they climbed out through the captain's sliding cockpit window while the rest of the aircraft burned behind them. Each of them came away with minor injuries, some from the impact and some from getting out through a window 3 meters above the ground. The safety board published its report in 2000, The probable cause was the captain's over-control of the airplane during landing and his failure to go around from a destabilized flare, with his concern about touching down early listed as a contributing factor. The report went well beyond the cockpit. It examined the MD-11's handling characteristics and its structural integrity requirements, the hard landing inspection rules, the limits of the flight control software, and the usefulness of the performance computer the captain had consulted. 12 safety recommendations went to the Aviation Authority. The most consequential of them concerned what a pilot should actually do when this aircraft bounces. Before Newark, there was no standard answer. Afterward, the authority required every MD-11 operator to train a specific bounce recovery technique, hold a positive pitch attitude, add thrust to arrest the sink, and let the airplane float down the runway to a second touchdown, rather than forcing it onto the ground. A passenger in first class had a reading light that would not come on. The flight engineer went to look at it, and on his way back into the cockpit, he brushed against the flap and slat handle on the center pedestal, knocking it out of its detent. Everything in this chapter follows from that. Flight 583 had left Beijing on the 5th of April 1993, stopped at Shanghai, and was 10 hours into the Pacific crossing to Los Angeles. 235 passengers and 20 crew, including a relief flight crew and 12 flight attendants. The captain was flying from the right seat, while his first officer sat in the left, training toward a command of his own. Slats are the panels along the leading edge of a wing. They slide forward and down to let the wing generate lift at low speed, which is what an airplane needs when it is taking off or landing at 150 knots. At cruise, they stay stowed. Extending them at 550 miles an hour reshapes the wing, while the aircraft is doing more than 3 times the speed the setting was built for, and all 8 segments on each wing came out at once. The autopilot disconnected immediately, and the nose dropped about 5.5 degrees. The captain pulled back and the airplane went nose up, so he pushed, and it went nose down harder, so he pulled again. Each correction arrived slightly late and slightly too large, so instead of settling the motion he fed it, and the aircraft went through several violent pitch oscillations while losing 5,000 feet. The cabin took the punishment. Most people had their seatbelts off because it was 1 in the morning and the airplane had been in smooth air for hours. The oscillations threw them out of their seats into the ceiling and dropped them back down, along with service carts and everything else that was loose. 255 people were aboard, and 156 of them were hurt, including 7 of the crew, and the interior came out of it wrecked. The captain got the airplane back under control and leveled off. The slats stayed extended because at that speed, retracting them was out of the question. He declared an emergency for the injuries and turned north for Shemya, a United States Air Force base on a small island near the western end of the Aleutian chain. It is one of the loneliest runways on Earth, and on that night it was the only one within reach. The MD-11 flew for 2 hours with its slats hanging out, then made an instrument approach in darkness and landed on runway 28 at 3:30 in the morning. Everything worked. The airplane taxied to the ramp under its own power, and Air Force personnel came out to meet it. 2 of the passengers had been injured too badly to survive. The rest of those aboard sat on Shemya for about 30 hours before another aircraft could get them to Anchorage. The safety board adopted its report that October. The probable cause was the inadequate design of the flap and slat actuation handle by the Douglas Aircraft Company, which allowed the handle to be dislodged from its stowed position easily and without anyone intending to. The rest of the report covered more ground than that sentence suggests. It examined the aircraft's longitudinal stability during the upset, which comes back to the same shortened tail McDonnell Douglas fitted to save fuel. It examined the pilot-induced oscillations that can occur while recovering from one, and found the crew had received no training in handling an upset at high altitude. It also examined the seat cushions, whose fire-blocking material had degraded well before it should have and would have left everyone aboard exposed in a fire. Douglas redesigned the handle. China Eastern repaired the airplane and put it back into service, and it was still flying 2 years later with a new interior and a new handle in the cockpit. The Pitot tube is a forward-facing probe on the nose that measures the pressure of onrushing air and turns it into the air speed on the panel. Each probe has 2 small drain holes so that water picked up in rain or cloud can escape. In 1974, a DC-10 operator reported an airspeed reading 30 knots off. The cause turned out to be manufacturing residue blocking those drain holes, and Douglas wrote to every DC-10 operator about it in January 1975. A detailed inspection of the drain holes became a required maintenance item on the type. The MD-11 inherited the same pitot system, the same probes from the same manufacturer, mounted in the same positions on the nose. When Douglas wrote the maintenance program for the new aircraft, the drain hole inspection stayed behind on the DC-10. Boeing added it as a recommendation in 1997, and in October 1999, a recommendation was all it was. The aircraft that would fly Flight 87 had spent that spring generating airspeed problems. On the 9th of April, its autopilot dropped out in cruise with a 6-knot split between the two displays. On the 13th, the crew got a 35-knot differential, and maintenance found the captain's pitot line obstructed with water and purged it dry. There were write-ups on the 25th of April, the 8th of May, the 2nd of June, and twice on the 26th of June. Engineers worked through the obvious suspects across those months, replacing both air data computers along with a temperature probe and 2 sensors, purging the lines and checking the system without ever inspecting the drain holes. On the 17th of October 1999, the airplane left Shanghai for Subic Bay in the Philippines with 2 pilots and a load of electronics and garments. The captain was 53 with 14,000 hours, though he had failed 2 MD-11 simulator checks before passing his upgrade to captain in 1996. The problem started 43 minutes before landing, at 37,000 feet, during moderate turbulence. The 2 airspeed displays began to disagree, and the autopilot disconnected, which on this aircraft happens automatically when the split reaches 12 knots. The captain's reading was low by exactly that much. He mentioned it and said he had no speed problem. As the descent began, the first officer told him it was happening again, and he answered that it had been there for a few minutes. Then the airplane started producing alerts, telling them to select elevator field to manual and to override the flap limit, mixed with overspeed warnings and further autopilot disconnects. The first officer worked the checklist for each alert as it appeared, exactly as she had been trained to do, and exactly as the aircraft's alerting system was designed to prompt. Every one of those alerts was a symptom of an air data failure. The checklists attached to them dealt only with the symptom, and left out the standby indicator sitting in the middle of the panel on its own independent system, showing the correct number the whole time. There was a checklist for this. It was called airspeed, lost, suspect, or erratic, and its 6th step was to compare the pilot instruments against the standby. Both pilots knew it existed, and both had gone their whole careers without training on it, so it stayed closed. At around 5,000 feet, the first officer suggested selecting a different air data computer, saying she did not know whose reading was right. They switched her instruments to the captain's side. The alerts went out, and the autopilot came back. She said they seemed to be back in business, having just put both of them on the faulty side. By now, the error had grown with the descent. Crossing the threshold at night on a wet runway, the panel read 151 knots, and the airplane was doing 196. The ground proximity warning called sink rate repeatedly, then called pull up about 100 feet above the ground. The company procedure for a pull-up warning at night is immediate maximum thrust and 20 degrees nose up. They landed instead, 25 seconds later, with 2/3 of the 9,000-foot runway already behind them. The MD-11 ran off the pavement, destroyed the localizer antenna, dropped 30 feet onto the shoreline road, and went into Subic Bay. The fuselage broke in 2 behind the cockpit. Both pilots climbed out of their own side windows as water reached the sills, swam through fuel to the right wing, and sat on it until a boat came. The investigation named the crew for the erroneous airspeed they never resolved and the go-around they never flew. It also named the clogged drain holes, the MD-11's insufficient alerting for airspeed anomalies, and the checklists that pointed nobody at the standby instrument. The first officer told investigators afterward that she had never used that instrument in her career at FedEx. Lufthansa had a written procedure for what to do when an MD-11 bounces, and its crews practiced it in the simulator: hold 7.5 degrees of pitch and apply go-around thrust. And above all, avoid large forward or aft movements of the control column, because changing the pitch rate quickly can break the nose gear or strike the tail. 2 Lufthansa pilots did the opposite of all of it, because as far as they could tell, the airplane had already landed. Flight 8460 left Frankfurt in Germany on the 27th of July 2010, carrying about 80 tons of freight, bound for Riyadh in Saudi Arabia, and then onward to Sharjah and Hong Kong. The captain was 39, the first officer 29, and both were properly licensed and current on the type. They flew an instrument approach to runway 33 left at King Khalid International in normal daylight visibility, arriving just before 20 to 12 in the morning. The airplane weighed 207 tons. On short final, the sink rate began to build and it got past both of them. The first officer was flying and he started the flare late, which at that weight left the aircraft coming down at 780 feet per minute when it met the runway, against a normal touchdown of around 120. The impact registered 2.1 G and the MD-11 came off the concrete again. The The Saudi investigators were clear that the accident had not happened yet. A bounce is recoverable, and this one was, right up until the crew responded to it. What they found was that both pilots read the first touchdown as the airplane being on the ground, so the captain pushed the control column forward, hard, to keep it there. He also took control without telling the first officer, which left both men flying at once, each making his own inputs on his own column. The airplane came down again about 2,100 feet further along the runway, flat at 11 feet per second, and the nose gear contact alone measured 3G. It bounced a second time to 12 feet, with the nose now pitched 14 degrees up. The captain pushed forward again, and then both pilots pulled back together. The third impact was 4.4 G, far past what the structure was built to take. It ruptured the fuselage behind the wing and severed fuel lines. The airplane broke, veered off the side of the runway, and the nose gear collapsed as it went. Fuel poured out and caught, and one of the pilots transmitted a mayday while the aircraft was still sliding. It stopped in the sand beside the runway, with fire taking hold of the middle of the fuselage. Both men got out on the emergency slide, one with minor injuries and the other in serious condition. Airport crews eventually contained the fire, by which time it had consumed most of the aircraft. The final report from the General Authority of Civil Aviation put it plainly. The severity of the second and third touchdowns did not follow from the first one. It followed from the pitch angle during the bounces, which came from what both crews did to the control column. On the captain's decision to push forward at the first bounce, when his own airline's procedure told him to hold attitude and add thrust, the report said the reason was unclear. His last simulator session covering bounce recovery had been some time earlier. A heavy aircraft touching down at 6 times the normal sink rate is a problem no procedure can fully solve. But the procedure existed for a reason. Boeing and Lufthansa had written it because this aircraft had already destroyed itself at Newark and again at Narita. And by 2010, the whole industry understood that an MD-11 bounce has to be flown differently from a bounce in anything else. The crew of 8460 had been taught that, and in the seconds when it counted, they were flying an airplane they believed was already down. On the 4th of November 2025, a UPS freighter began its takeoff roll at Louisville in Kentucky, bound for Honolulu. The left engine and its pylon came off the wing. The airplane never got much above 30 feet before it came down beyond the runway into an industrial area and burned, taking the 3 crew and 11 people on the ground with it. Within days, the Federal Aviation Administration issued an emergency airworthiness directive covering every MD-11 on the planet, requiring structural inspection before any of them flew again. UPS grounded its fleet on Boeing's recommendation. FedEx and Western Global followed, and for the first time since December 1990, the entire type sat still. UPS decided the inspections and repairs would cost more than the airplanes were worth to a company already replacing them. On the 27th of January 2026, it confirmed that all 27 of its MD-11 freighters had been permanently retired and took a $137 million write-off to do it. The fleet averaged 32 years old, and the oldest airframe was 34. UPS had been planning a phased exit anyway and simply moved the date forward. FedEx read the same accident and went the other way. It had 58 MD-11s, more than twice as many, and it kept them parked for 7 months while the inspections ran. Then it started putting them back in the air, retiring 10 of the oldest and returning the rest to service. It also pushed the retirement date for the whole fleet from 2028 out to 2032, because it wanted the wide-body capacity for a push into international freight. McDonnell Douglas and Boeing built 200 MD-11s between 1988 and 2000. 10 of those airframes have since been written off, and 5 of the 10 took people with them. Counting the 2 lost over the Pacific in an airplane that was repaired and flown again, the total across the type comes to around 258. None of this was how the aircraft was supposed to end up. McDonnell Douglas designed it for Airlines as a long-haul flagship that would keep the company in the wide-body business against Boeing and Airbus. It sold 200, which was not enough. Boeing bought the company in 1997 and built the last of them in 2000 before closing the line. The passenger airlines left first. By the early 2000s, the twin engine jets had won on economics, and the flag carriers moved their long-haul flying onto aircraft with 2 engines and lower costs. KLM flew the last scheduled MD-11 passenger service in October 2014, with farewell flights that drew thousands of people to Schiphol to watch it go. The cargo operators took over from there, and that is the life the type actually had. Cheap to buy secondhand, big enough to be useful, capable of crossing oceans with a full load. FedEx and UPS between them ran most of the world's remaining fleet, flying them at night, into airports in weather, at the end of long rotations, which is the operation nearly every chapter in this video came out of. What those crews were flying was an airplane that lands 15 to 20 knots faster than the one it replaced, and carries less structural margin above its design sink rate. The shortened tail that made it efficient took away pitch damping, so a pilot correcting a bounce or an upset can make the next swing worse without meaning to. 3 different countries have written safety recommendations about the software fitted to compensate for that. All of this was understood inside the industry. The bounce recovery technique that came out of Newark went into every MD-11 operator's training program, and the crew at Riyadh had rehearsed it in a simulator. Western Global Airlines has reactivated 2 of its MD-11s. They are flying under contract to the Pentagon, hauling freight to American bases in Europe, 35 years after the type entered service and a few months after the whole world grounded it. Thank you for watching, and don't forget to subscribe to Terra Obscura.